The world's largest and most powerful space telescope has revealed unprecedented views of Jupiter. James Webb Space Telescope has hardly opened its eyes when something truly extraordinary unfolded in the vast expanse between Mars and Jupiter. A region teeming with ancient asteroids, remnants from the early formation of the solar system. This place, known as the asteroid belt, is often viewed as relatively stable. Occasionally, a rogue rock tumbles through it, nudged by gravitational forces. But nothing had ever quite resembled what was recently captured, streaking across this domain by the James Webb Space Telescope. What crossed this region wasn't a mere rock, nor was it just another icy comet. It was something altogether unfamiliar, something that shimmered, pulsed, and moved with a strange intent. Before we start, smash the like and subscribe buttons for more updates. The James Webb Space Telescope, stationed nearly 1 million miles from Earth at the second Lagrange point, was scanning a segment of the asteroid belt as part of a broader mission to study the early solar system's composition. During routine imaging, Webb's near-infrared camera and IR cam picked up a faint but highly unusual object. It wasn't cataloged, wasn't listed in any near-Earth object registry. Its trajectory didn't match that of any known comet or asteroid. It was fast, far faster than a typical asteroid, and glowing, not just reflecting sunlight, but emanating a deep, eerie luminescence. The object appeared to be cloaked in a metallic sheen, with spectroscopic readings suggesting materials not commonly found in natural celestial bodies. The object's motion wasn't erratic as one might expect from a piece of debris thrown into the void by a collision. It was smooth, curved, and oddly deliberate. It accelerated briefly, then slowed as it neared the more densely populated region of the asteroid belt. It weaved through the rocky terrain as though it were avoiding obstacles. Webb's instruments continued to track it as it emerged from the inner edge of the belt and passed near the orbit of Vesta, one of the largest objects in the belt. At that point, something even stranger happened. The object paused for several minutes, hovered in space, rotating slowly. This wasn't tumbling. It was a steady, balanced rotation, as though scanning the surroundings. Telescopes on Earth were quickly redirected to confirm what James Webb was witnessing. But the resolution from ground-based observatories couldn't match the detail being funneled back from Webb's instruments. Still, the consensus was clear. This was no ordinary natural body. Infrared signatures showed high internal temperatures, inconsistent with frozen comets or metal-rich asteroids. Some readings even hinted at energy emission structured pulses on frequencies not typically associated with known natural phenomena. These signals bore a rhythm, not entirely regular, but with enough pattern to draw attention from scientists and engineers alike. As the object resumed its course, it veered closer to Mars' orbital path before adjusting and continuing on what appeared to be a shallow, curved trajectory, now arcing out of the plane of the ecliptic. It was climbing above the usual alignment of planetary orbits, a path that required substantial energy input if the object were under propulsion by this point. Speculation had turned to fever pitch. Was it an undiscovered type of comet with highly reflective materials? Was it a piece of ancient debris from a long-lost probe? Or was it something else entirely? Something perhaps not of this world, the James Webb Telescope never intended for. Tracking fast-moving objects was pushed to its limits. Engineers and mission control recalibrated the tracking systems manually to follow the object as long as possible. Its near-infrared spectrometer detected anomalous compounds along the object's surface, some resembling synthetic polymers, others emitting in the microwave band. Completely outside the thermal expectations for an asteroid, the data indicated. It was composed not merely of rock or metal, but of complex layered materials, some of which showed signs of structural lines inconsistent with natural geological formation. By the time the object reached the edge of the asteroid belt, it had traveled nearly 1 million kilometers in a matter of days. It never slowed as it reached this boundary. It merely shifted angle again and disappeared into deeper space, now moving toward a trajectory that would take it above the plane of Saturn's orbit. Webb sensors eventually lost track of it due to angle constraints and limitations in follow-up positioning. But not before it captured one final spine-chilling detail. A burst of light from the rear of the object, faint but distinct. It resembled propulsion, but not chemical. The burst had no thermal signature, no plumes, no dispersion clouds. It was an emission of pure directed energy, something no known spacecraft in Earth's inventory could replicate. The implications of this event rippled through the scientific community with shockwaves. First, it called into question everything presumed about the predictability of our local space environment. The asteroid belt, long considered a relatively well-mapped region, had just hosted something totally unexpected until it was already deep within. This raised urgent questions about our ability to track objects that may not reflect sunlight in traditional ways. Perhaps there are other such objects, dark, fast, and deliberate, that have already passed us by undetected. If this object could maneuver and even pause mid-space, it implied a level of control, which, if not artificial, would require a natural phenomenon so advanced it bordered on intelligent behavior. This wasn't merely a disruption of orbital predictions. This was a shift in our understanding of what could exist within our own solar system. Scientists scrambled to re-examine data from older telescopes, archival records of deep space monitoring missions, searching for anomalies they might have previously dismissed. With this new lens, even mundane glimmers and transient data spikes took on new significance. Was this object truly the first of its kind? Or the first we had noticed? What made this event even more compelling was the absence of any tail or debris trail. Comets usually give off volatile gases and dust when approaching inner regions of the solar system. But this object remained sealed, clean, and controlled. Its path cut through the asteroid belt with precision, never deviating from a controlled curve. Even while dodging dense clusters of space rock, its velocity varied in ways that defied gravitational logic hacks, accelerating as if under internal power, not external gravitational slingshots. Researchers in propulsion physics examined the spectral data again and again, and one pattern became harder to ignore. The pulses of radiation emitted as the object moved had harmonics, layers of frequencies nested within each other, not unlike music. This wasn't white noise or thermal radiation. It had tonal properties, as if carrying structured information or operating on multiple data channels. Could the object be emitting a form of signal? If so, to whom or for what purpose even? Within the context of natural celestial oddities, this object stood alone. No meteorite, no asteroid, no comet ever exhibited such an ordered path with simultaneously chaotic composition signatures. What the James Webb Telescope had recorded was something unclassifiable under current astronomical standards. It didn't match any of the usual suspects, nor did it fit neatly into fringe categories like interstellar visitors akin to Oumuamua. Unlike Oumuamua, this object was not tumbling, not randomly shaped, and it didn't rely on solar radiation for motion. Some theorists began to consider whether it might be a probe, not one from Earth, but an observer. A reconnaissance craft from a distant origin, maybe even outside the solar system. Such an idea was speculative, but the object's silence, its graceful path, and the apparent propulsion signature all suggested a level of design. If it was a probe, then perhaps it was not meant to land. It's not meant to interact, but only to pass through, observe, gather, and leave. The asteroid belt had just played host to a visitor, one not announced by gravitational waves or massive energy signatures, but one that glided through as silently and efficiently as a thought. It didn't touch anything, it didn't disrupt the natural order, but it was seen. The James Webb Telescope caught it all. This moment was a rupture in the assumed boundary between the known and the unknowable, quiet shimmering. Passage that rewrote the rules without a sound. It may take years, even decades, to fully analyze the data captured in that fleeting window. Every burst of light, every spectral anomaly, every shift in trajectory will be pored over with a level of scrutiny rarely afforded even to major planetary discoveries. Researchers from multiple disciplines, astronomy, material science, propulsion, engineering, signal theory, will dissect the event from every conceivable angle. It won't just be astronomers looking skyward anymore. Physicists will question propulsion principles. Biologists might ask what such an object could be sensing or analyzing. Philosophers will confront the silence it left in its wake. This event, cast a long shadow. Not because of any danger, there was never a threat of collision, but because of the deep, unsettling possibility. It suggested that something else is out there. And it may have already passed us by without pause, not as an invasion, not even as a greeting, but as an indifferent traveler through our local space. And if it has been here once, what else may have crossed these same borders while our eyes were closed?